area of regular polygons. And they involve the triangles on the inside. Okay, here's a formula. And there's a special word that applies only to polygons, whether it's a hexagon or an octagon or a decagon. It has a special word. The area of a regular polygon is half. That means you're going to be dividing by 2, just like the triangles. Half the product of the APOTHEM. The apothem. And from that, and the perimeter. Okay, so if you can find the 2 parts that you need, you could just use this formula. You are still going to have to multiply by however many sides there are. You are still going to have to try to find the missing angle, the central angle there. But you might find this easier because the formula is there to begin with, and you just plug in what you need to know. The first page is going to be extremely easy. The second page is where they get trickier. The apothem, write down this definition. It's the segment from the center dot of a regular polygon that is perpendicular to a side. So it can't go to a corner. It has to go straight to the middle of a side. It's like the height of that little triangle right there. Okay, so this is the little A right there. That's the apothem. And it's confusing at times because you don't know if you're talking about the adjacent or the apothem. But actually, they come out to be the same. Okay, so the formula. In this case, you could do area equals the apothem, the little a, times the perimeter divided by 2. So look at it. There's 5 triangles there. Every triangle has a height of what? Okay, 11, or the little a. And every triangle has a base of what? 15. So what they're doing here is they're just going to multiply that all by 5 to begin with rather than waiting till the end. So the apothem is 11. The perimeter is one side of 15 times how many sides do you have? 5, and that equals 75. Okay. So some of you are going to find this one easier. Either way is fine. Some people like to see the visual of the other ones. Some people like this one because you take care of the whole formula just at the beginning. And now you plug in. Apothem is 11. Perimeter is, you guys know perimeter means all the way around the edges, right? Yeah. 11 times 75, and then you divide by 2. So what do we get for that one? It's just combining all the 5 triangles into one to begin with. This is the area of a triangle. Base times height divided by 2. They just do all 5 of them. 412? Like that. And that one was feet squared. Okay. Now, if you're given the information, it's really easy. If you're not given the information, then we're still going to use SOHCAHTOA or else Pythagorean theorem to figure out what's missing. Okay, questions on that?
Nope.
Let's try another one of the really simple ones before we get to the complicated ones. The next one. The apothem goes from the center to the edge. So looking at this problem, the apothem is what? 12. It's from the center to the edge at a right angle. It's got to be at a right angle, 12. The perimeter, one side is 10, but how many sides are there? 8. So the perimeter would be 80. And that's like multiplying all the bases of the triangle together right there. So the formula is area equals the little apothem times the perimeter divided by 2. So it's all 5 triangles combined into one. So the apothem, you just plug in now 12. The perimeter is 80. And divided by 2. 12 times 40, is that 480? No, it's 6 times 80. Okay. And that's meters squared. Any questions on that? All right, now let's turn the page and let's deal with one where all the information you need is not given to you. The only time these get tricky is when you're missing some information and you have to think back to all that stuff we did with SOHCAHTOA so you could find the part that's missing. And we're going to deal with The SOHCAHTOA as necessary, only if a part that we need is missing. So, what do you think the apothegm is in this polygon? The apothegm is the one that comes straight down. Do we know the apothegm?
Yeah.
That's actually the hypotenuse. The hypotenuse has to, I'm sorry, the apothegm has to go to right angle, so that one's not going to be it.
Oh, I thought that was a little a.
Yep, the little a is the apothegm. That's the one that's going to have to come down at a right angle. So it's actually unknown. Do we know the perimeter? No. So those are the things we're going to have to find so we can use the formula. Okay, so we're going to have to make our little triangle here, and the slanted side is 6. Before we cut it in half, we need to know what degrees we're dealing with. So we always start with 360, and we divide by the number of sides. How many sides here? 5. So if I remember right, that makes 72. Please correct me if I'm wrong. Okay, so this angle right here is 72. Those of you that were absent, it's right here. You take the 360 and divide by the number of sides. All right, that's all the way across. But if I just want to deal with this one little triangle on its own, I'm going to have to split it down the middle to find all the parts I need, and then I'll go back to the big thing. All right, so take that triangle and split it down the middle. You're cutting everything in half, and when you do that, you're forming a right triangle right there. What are the degrees right here? 36. You're cutting in half. 36 and 36. That's the focusing. We need base. We need height. That's going to, actually, we don't need the base, do we? Yeah, actually we do. We don't know the perimeter yet. So we're going to need to find both, just like yesterday, but then we'll plug it in the formula. So call this one X and call this one Y. You need to know the base. This is not equilateral. It's not a 60 degrees, so we don't know that this is 6. In fact, it can't be 6. All right, so let's find this one first. Can you do it without me writing the letters? If you choose X and 6, what word that would be? Sine. Good. That's the opposite. That's the hypotenuse. So do the sine of 36, and it equals opposite X over 6. Cross multiply it. There's no dividing because the X is on top. Make sure your calculator is in degrees, and tell me what we got. 3.5. Sounds good. We all agree? Please tell me if it's not 3.5. Okay. For the y, if I want to use y and 6, which word would that be? Y and 6? Cosine. The cosine is, the y is adjacent, the 6 is the hypotenuse, so the cosine of 36 equals the y over 6. So, multiply 6 times the cosine of 36. What do we get for that one? 4.9, rounded to that. Okay. So now look what we have. We have the apothegm, 4.9. We don't have the perimeter yet, but the perimeter would be pretty easy to see. Yeah, what would this whole entire side right here be? 7. And how many of them make up the perimeter? 5. So you can find the perimeter that way. Okay? So the area equals the apothegm times the perimeter divided by 2. So help me out here. The apothegm is what number? Or 0.9. The perimeter is not 7. What's the perimeter? 35. 7 times 5 of them. So the perimeter is 35, and then you divide by 2. So work that one out. 75.8? 85.8? This is what I heard. Please double check that. Let's see.
Thank you.
Okay, so the only difference is that you write the formula at the beginning, you figure out what the apothegm is, and for the perimeter, you have to remember to multiply by how many sides there are. So you're going to be trying a few this way, and then you're going to be picking which way works best for you. Anyone still ready? Okay. Everyone else who's done, please turn the page why number 10 is going to be easier than one distance? You already have the 12. Yep, you already have the ability to find the perimeter. All we're going to have to do now is try to figure out what the apothem would be. You were on the right page. Over one more. Okay, okay, so number 10 is going to be easier because we already know the 12. So we're going to draw the triangle that we need. That's going to help us find the apothem. Or if we were doing it the other way, it would help us to find the height of the triangle. We need the apothem, and we need the perimeter in order to use our formula. Okay, we could... Yeah, we're going to have to use SOHCAHTOA. So what's the degrees right here? How do I find it? 360 divided by 6 sides. You get 60. When you're trying to find the apothem, you cut that right down the middle. You make a right angle. So what's this angle right here? 30. Some of you right now, some of you stop and say, hey, that's a 30, 60, 90 triangle. I know how to do that. Okay, if you do, great. Use that shortcut. If you don't, the one that always works every time is SOHCAHTOA. So you can always go with that one also. All right, we already know this side. What's this side? 6. Good. Because the whole base was 12. But this is the one we don't know. Right there. So if I know 6 and I don't know x, which word could I use? Tangent. So a lot of it is the same. The tangent of 30 degrees is going to equal 6 over x. So you're going to multiply the two numbers or divide? Divide 6 divided by tangent of 30. Tell me what we get. Let's do nearest 10. 10.4? And what we found there was the height of the triangle or else the apothem. They're the same thing.
Hey.
Alrighty. So then we have everything we need now. We know that the apothem is right here. And we have to figure out the perimeter. What's the perimeter going to be? One side is 12. And there are 6 sides of 12, so that's going to be 72. So I'm going to leave the screen and go into the other picture so that we can combine it all together. So we found that the apothem was 10.4, and we found that the perimeter was 72. So use the formula, area equals apothem 10.4 times the perimeter 72, and divide it all by 2. What'd you get? 374.4. And that one would be inches squared because it's area. Okay, so that's another way to do it. Either way, you still have to find the side of the triangle, and you have to find the height of the triangle, whether you call it height or apothem, you have to find both.